Okay, this is just a recap of stats from the first assessment task that we had, and we're going to be looking at 6 areas. We're going to be looking at sampling and sampling size and population mean, as well as stratified samples, box plots and outliers, and hopefully that all kind of makes sense as we go through here. So let's kind of start off here by looking at sampling. The reason why we do sampling is because if you get the whole population, which is everyone in your region that you're looking at. So if you're looking at teenagers in Australia, your population will be all teenagers. But you can't interview all teenagers, so therefore you've got to look at for something else slightly different to do. So what we do is we do a sample of that. We grab a subset of it, and it's got to be large enough so that you get some good data. The choice of people who take your sample should be random, which means that every person has an equal choice of being selected, so no bias is hid there. The other thing is there are the two kind of ones that we look at. It's called systematic sampling, where you might randomly pick the first person and then pick every 7th person from there on in. So it's a system that you're following. However, you're starting with a randomly chosen person. So that's one way. The other way is just randomly pick numbers and keep on going until you get your quota, until you get the number of people you need. That's called quota sampling. So those 3 things you need to remember: random, where everyone has an equal chance of being selected; systematic, where you might set up a certain repeating pattern of how you choose people, starting off with a random person; and also quota, where you keep on going until you get the right amount of people. So let's have a look at sample size. For sample size, we've got to be able to pick the right number of people we need for our survey. Now, there's a couple of formulas you can use, but this one's pretty good. This one's the one that we will use in this course. It's using the square root of n plus 10% of n, whereas n is the actual population. Okay, n is the number of people that you're looking at. So when you do that, you end up going square root of 850, add 10% of 850. So when you do the square root of 850, you get 29.1 plus 10% of 850 is 85, which will then give you an answer of 114.1. Now you can't have 0.1 of a person when you survey them, so you've got to either round down or round up. I suggest that you round up. Okay, so 115 people, because then that means that your sample is going to have a few more in there. So if you have a look at it, once again, n is your population. Okay, so n is the population, the number of people you're looking at, and the formula is the square root of n, add 10% of n. So our population in this case is 850. We found the square root of 850, which is 29.1. We found 10% of 850, which is 85. We've added the two together, we get 114.1, and we've rounded up to 115 people should be in that sample for it to be representative of the population. Okay, we're looking for that whole thing of representative of the population. So how do you know if your sample is representative of the population? Well, we have a look at a thing called the population mean and the sample mean. The population mean is when you grab everyone in your population and find the average, and your sample mean needs to reflect that. So let's say that your population mean, let's say it's 75.6, I'm just making this up, and then your sample mean is 33, then I'd be saying that your sample's not big enough. Okay, it's not big enough because it doesn't represent. See how this one doesn't reflect the population mean. 76.5 is nowhere near 33. However, if this was, say, 70, I'd say, yep, you're pretty cool, because that's pretty close. Your sample mean is reflecting your population mean. So you need to be careful that you mention that in terms of sample size. Your square root of n plus 10% of n will give you a number, as long as your sample then reflects that in your population mean reflecting your sample mean. Okay, so there's those things there to do with that. Now, your sample mean must reflect your population mean. Okay, sample mean must reflect the population mean. So please remember that kind of terminology, because that's what you need to write in a written question when it says, is this sample big enough? Okay, dokie. Now, one of the sample techniques that we'll be tested at is called a stratified sample. A stratified sample takes into account the characteristics of the population. So once again, giving you a sample that's reflective of the population that you've got. So it takes into account the different things that happen. So things like your gender, it might be a gender one, or it might be socio-economic background, it might be age, all those kind of things is what we mean by characteristics of a population. So if you've got a sample which has different characteristics in it, you need to make sure that the characteristics of the whole population are represented in your sample. And that might sound a bit kind of Goo-garish, but if we have a look at an example, and the best way to kind of think about this is like a school. Okay, so we've got a school here, which is quite a nice school, and it's got all these people in it. Okay, what we need to do is, you can notice from here that we've got a lot of year 12s here, hardly any year 11s, and then we've got our next biggest group is year 9s, etc., etc. So we want to do a survey and sample 50 people. Okay, so if we add up our population of our school, our entire population is 157. So we've got 157 people to choose from, and we only want to sample 50. We want to come up with a sample that's representative or reflects this group of people here. Reflects the fact that there are more year 12s and year 11s. So in our sample, we could have more year 12s and year 11s. So let's have a look at how we can do that. We go to this here. What you do is you grab your year 8 level. So let's have a look at our year 8 level here. We've got year 8. Our year 8 level is 27 kids divided by 157 times by 50. Okay, our sample is 50. Our sample is 50 here, and our total population's there, and the number of people in that grouping is there. So if you have a look at, you've got year 8, year 9, year 10, and you can just see it reflects all the way through. So when we actually solve that out, we get 8.6 is in here, 12.74, 9.55, 3.18, 15.92. So I've got the characteristic of the group that we're looking at, the total population, and the survey size. And notice how these are all in decimals. Now we've got to be careful, because you can't, as we said before, you can't survey point something or other of a person. It's very hard to find 0.6 of a person. So we've got to look at rounding up and rounding down and those kind of things. You've also got to then have a look at the characteristics within your whole population. So I've gone 15.92, I've gone up to 16. 3.18, I've gone to 3, that makes sense. 9.55, now that should go up to 10. Well, 8.6 should go up to 9. So how do I work out the difference between them? You can see that here I've got 30 people there. So it's kind of easy way. You could either go up to 10 for this and 8 for that one, or 9, and I've gone 9 and 9 because I thought 27 is pretty close to 30. So if I was looking at it to say, okay, I've got to make that split. Do I go up here, or what do I do? I'd be saying there's 27 kids in year 8, so therefore we should choose 8 people. There are 12.74, so that goes to 13, then 10, then 3, and 16. And if you add them up, you get 50. So you've got to make sure that you add them up. So you can see that the weightings, the relative groupings or size of groups in the school are being reflected in the survey. Everyone's got an equal chance of being selected if you set it up randomly. Therefore, that's called a stratified sample. Okay, stratified sample. Very important to know that one. Let's have a look at the next thing. The next thing is box plots. Box plots basically use the 5-number summary. Now the 5-number summary comes off your graphic calculator. Okay, so if you want to get these numbers here, I just made up these numbers here. These are, I don't know, let's say there's someone's body temperature. If I get the calculator and enter them into my stats thing, I'll get a whole list down here. Okay, that's all the numbers being added in there. So if I then go to one variable, I just make sure that I've set it up that list 1 is being used. So I've gone to F6, list 1's being used. Excellent. Come down to this one here, and it will do the calculations for me. So you can see that's X bar is your mean, and we keep on scrolling down. Our 5-number summary takes into account our minimum, our quartile 1, our median, our quartile 3, and our, oops, I've lost it again, and then our maximum. So that's our 5-number summaries. There are 5 numbers there. That's why it's a 5-number summary. It's quite logical. So let's have a look. So our minimum we've worked out is 22. Our quartile 1 is 29.5. I'll just see if I can squeeze it in here. Our median, which is our middle score, is 35. Quartile 3 is 40.5. And then our last one is 105 for our maximum. So when we draw a box plot, what we do is we've got to draw with a ruler. Okay, I haven't drawn it with a ruler because it's very hard to hold a ruler on the screen of a computer. I've tried, but it just seems to dismally fail. So you can see what I've done here is I've got it all set up so I've got a number line that gives me a scale. Okay, notice that I've got it in that kind of going up in tens. I've got a title, which is body plot of body temperature. Now you could probably go degrees Celsius as well. And then I've put in the box plot, and I've grabbed the numbers from my minimum, my quartile 1, my median, quartile 3, and maximum. And you can see I've labelled it like that. So you can have a look at that box plot, and you can see that there's some information here. It's going through here, and then number 105 is way out here. So that's just massive. Now, in terms of what's happening, 25% of our data is in this section here. Then 25 in here. So I'm going to run out of room. 25 in here, 25 in here. So each of those little segments is like a quarter of our data. You can be looking at that and going, hang on a tick, this number 105 here is way away from everywhere else. It's way away from everywhere else. So maybe that is an outlier. So if it's an outlier, we need to be able to test for it. Now you can do it in the graphic calculator, and you can also do it manually. So let's have a look at the graphic calculator way first. If I pull up the calculator and drag it over here, let's look at how we draw that graph. If we come back to our first window, which has got our list in there, we want to go to graph, which is F1. We hit that there. And we want to set up our graphing. So we want to set it up, and we have a look. It goes stat graph 1, which is the one we want to draw, and it's got graph type is a scatter plot. Now we don't want a scatter plot, we want a box plot. So if you just use the arrow keys down and then move it across, you'll come across to a box plot. Now depending on your calculator, it might have M box or just box. It's the median box plot that we want, so the M box. So when we've done that, it says I'm now going to be drawing a median box plot. I'm using my values from list 1, and the outliers are turned off. Cool. Now what we're going to do is then go to select, and select will tell us if we're going to actually be drawing that one. So stat graph 1, which is our first one, is turned on. If you had another lot of data, you might want to draw another graph as well, so you'd turn that one on by just going to this F1 toggle. But we just want that one to happen. If we draw it, it looks like that. You can see that looks pretty close to the one that I've already got there. Whoops, I can't get it to work, so I'll give up. So it looks like that with that big outlier over there. You would have noticed. So that's how we can check to see whether we've actually drawn our box plot properly. And if you want to check the numbers, you can go Shift F1 for trace, and see how we've got down here the minimum 22. If we click across, gives us our quartile 1, our median, our quartile 3, and our maximum. So it shows us all our values as we click across. So it means you can sketch your graph beautifully. Now, remember when we set this up, we went to Setup, and we came down to here and it said Outliers Off. If we come down here and turn them on, what will happen, the calculator will now see if there's any outliers there and indicate that on the graph. So we'll go to Select, that's good, go to Draw, and notice that it's picked this one here, which you would have picked as well because it's way away from everything else. Notice our box plot becomes nearly normal, so each of these little quadrants, these 4 bits here, are equal, and when that's equal it means it's a normal distribution. But we've got this little one out here which is an outlier. Now, because this is body temperature, you're probably thinking to yourself, hang on a tick, no one's going to have a temperature of 105, because if they do that, you'd be able to cook an egg on their forehead. So we know that's an outlier, but we've got to test for it. If it says in a test or something like that, you need to test for an outlier, you need to show mathematically how you do it. This gives you an idea of what's there, but mathematically you've got to show us. So this is how you do that as well. It gets a bit kind of long and boring, but bear with me, you'll get there. So with our outliers, we've got to look at our interquartile range. Our interquartile range is from the interquartile range comes from Q3 take away Q1. Okay, so in our case, Q3 take Q1 is 40.5 take 29.5, which gives us 11. Okay, so that's 11 is our interquartile range. What we then do is go 1.5 times our interquartile range, which will then give us a value that will say any number outside this value is an outlier. So if we go 1.5 times 11, we get a grand total of 16.5. Okay, so now what we do is we grab the quartile 3 and we say anything above quartile 3 plus 16.5 can be counted as an outlier. Anything below quartile 1 and 16.5 is an outlier as well. So let's go back to look at our picture. If we go back to our picture, we're saying that down here, oh dear, that's bad. There we go. We're saying that anything below 16.5 numbers away from here, oh dear, doesn't like me, down here, is going to be an outlier. Anything 16.5 numbers greater than that bit there is an outlier. Okay, so that's what it's doing graphically for us. So let's go back to our outliers page. So it looks pretty well much like that. So if we go 40.5 add 16.5, we get 57. And then 29.5 take 16.5 gives us 13. So what it means is any numbers larger than 57 is an outlier. Any numbers smaller than 13 is an outlier. So when we go back and look through our data, we can go through here and there's no numbers less than 15, but there is one number here which is 105, which is obviously above 57. So we can legitimately take that out of our data and therefore recalculate. So on the calculator it would look like this. You've got your little graph thing showing your outliers. You go exit, you come back into here, you find your 105, which is right down the end there. Whoops, went the wrong way. Oh, there we go. And then let's go delete, and it will take that number out. Okay, we can then redraw our graph and see how it comes up like that, and it's pretty well done. So it gets rid of the outlier and it changes things around. You could redraw that if you wanted to. The easiest way is just go shift and trace. Your minimum is still 22, that hasn't changed. Your quartile 1 has changed a bit. So our quartile 1 is now 29 instead of 29.5. Our median has changed, it's 34. The upper quartile is now 38, and your maximum is 47. So it's made your data nearly normal because these little 4 areas are nearly exactly the same in distance, and it's better data because you've got rid of that outlier. Okay, so that's how you get rid of outliers as well, which is a really good thing to do. So that's a recap of what was in that first test. Hopefully that kind of clears some things up for you.